Axioms, postulates and theorems. In this module, you will learn about axioms, postulates and theorems. Axioms. Many statements which are self-evident and can be accepted without any questions are called axioms. Euclid used the following statements which he called common notations. Here we will learn about some axioms. Axiom 1. Things which are equal to the same thing are equal to one another. For example, draw a line segment AB of length 10 cm. Draw a second line segment CD having length equal to that of line segment AB using a compass. Measure the length of line segment CD. Do you observe that line segment CD has same length equal to 10 cm? You may write this as CD is equal to AB and AB is equal to 10 cm, implies CD is equal to 10 cm. Axiom 2. If equals are added to equals, the wholes are equal. For example, suppose you have two line segments AB and DE of equal length. Add BC to AB and add EF to DE. If BC is equal to EF, then it implies that AC is equal to DF. Axiom 3. If equals are subtracted from equals, then the remainders are equal. For example, suppose you have two line segments AC and DF of equal length, remove BC from AC and EF from DF respectively. If BC is equal to EF, then it implies that AB is equal to DE. Axiom 4. Things which coincide with one another must be equal to one another. This means that if two geometric figures can fit completely one into the other, then they are essentially the same. Axiom 5. The whole is greater than the part. Take a container of water. Remove some water from it. Will the remaining volume of water be the same as the original volume? Obviously, no. Now let us learn about some geometrical postulates. Apart from these common notations, Euclid also made the following geometrical postulates to deduce new propositions. Postulate 1. A straight line segment can be drawn joining any 2 points. Postulate 2. Any straight line segment can be extended indefinitely in a straight line. Postulate 3. Given any straight line segment, a circle can be drawn having the segment as radius and one endpoint as center. Postulate 4. All right angles are congruent. Postulate 5. If a straight line meets two other lines so as to make the two interior angles on one side of it together less than two right angles, the other straight lines will meet if produced on that side, on which the angles are less than two right angles. The postulate 5 is the famous Euclid's parallel postulate. What it asserts is that two distinct straight lines in a plane are either parallel or meet exactly in one point. Let us revise all that we have learnt in this module: axioms, postulates and theorem.
is the next number in this sequence? 1, 5, 12, 22, 35. A similar sequence can help us make sense of this one. 1, 3, 6, 10. We can represent these numbers in a triangle, so it makes sense that they're called the triangular numbers. There's a formula that can help us find any triangular number. In general, the nth triangular number is n times n plus 1 over 2. There's a similar trick for our original sequence. If we represent them visually, we can see that they can form pentagons. Unsurprisingly, they're called the pentagonal numbers. Each pentagonal number is the sum of 3 triangular numbers. The 5th pentagonal number is composed of the 5th triangular number and the 4th triangular number times 2. We can use the formula from before to find these numbers. Cancel out the 2's on the bottom to simplify things. Then we can add these together to find the answer, 35, which is just what we expected. We can use this pattern to find the next number in the sequence as well, which is the 6th pentagonal number. The 6th pentagonal number is composed of the 6th triangular number and the 5th triangular number times 2. Again, using the formula from before, we can find these numbers and add them up to find the answer, 51. This pattern can be used to find the nth pentagonal number, whichever one we want. It's composed of the nth triangular number and the n minus 1th triangular number times 2. Which looks like this if you write out the formulas. Now let's use this pattern to quickly find the 10th pentagonal number. Just substitute the n with 10, and you'll get the answer, 145. Now that we know about pentagonal numbers, we're ready to look at centered hexagonal numbers. These begin with 1, 7, 19, 37. As you might expect, we can visually represent them with hexagons. What is the 6th centered hexagonal number? Triangles are useful here too.